When you are producing chemicals on a commercial scale, the reactions involved typically result in the formation of multiple products, but usually only one or sometimes two of those products are considered useful or desirable, while the others are essentially treated as waste. For instance, in one common reaction, the main goal might be to produce hydrogen gas, but carbon dioxide is also formed, which in this case is an unwanted byproduct. The generation of waste products like this is a frequent occurrence in industrial chemical processes, and it is important for companies to have a way to measure and understand exactly how much of the starting materials, also known as reactants, are actually being turned into the desired product. This allows them to gauge efficiency and profitability. This measurement is known as atom economy, and it provides a percentage that shows what proportion of the mass of the reactants is converted into useful products. The formula for calculating atom economy is to divide the relative formula mass of the desired product, or products if there is more than one, by the total relative formula mass of all the reactants used in the reaction, and then multiply the result by 100 to convert it into a percentage. Let's consider an example where the aim of the reaction is to produce hydrogen gas. Hydrogen has a relative formula mass of 2, since each hydrogen molecule contains 2 atoms with a mass of 1 each. The reactants in the equation are carbon monoxide, which has a relative formula mass of 28, and water, which has a relative formula mass of 18. When we add the masses of both reactants together, we get a total of 46. To calculate the atom economy, we take the relative formula mass of the hydrogen, which is 2, divide it by the total mass of the reactants, which is 46, and then multiply the result by 100. This gives us an atom economy of 4.35%. This is considered very low because it means that only 4.35% of the mass of the reactants is turned into the product we actually want, while the remaining 95.65% becomes waste. Most reactions used in industry aim to have a much higher atom economy, though in some cases it can be even lower than this example. Now, let's look at a reaction that has a very high atom economy. When nitrogen reacts with hydrogen to form ammonia, all of the reactants are used to make the desired product, which in this case is ammonia, and there are no additional waste products. This means that the atom economy of this reaction is 100%, making it highly efficient and desirable for industrial purposes. Understanding atom economy is essential for several reasons. Firstly, raw materials are often costly, and if most of them end up as waste, the process becomes less profitable. Secondly, from an environmental and sustainability perspective, it is inefficient to use large quantities of reactants just to make small amounts of useful products. Thirdly, the waste products themselves can be problematic, both because they can be harmful to the environment and because it costs money and resources to dispose of them safely. To solve the problems caused by low atom economy, industries try to improve the efficiency of the reactions they use, or they attempt to find a commercial use for the byproducts, effectively turning them from waste into useful secondary products. Even if these secondary products are not highly valuable, they are still better than having to spend money on waste disposal. Lastly, while atom economy is a very important concept, it is not the only factor that influences whether a chemical reaction is considered profitable or suitable for industrial use. Other crucial factors include the percentage yield of the reaction, the cost of the raw materials used, the position of the chemical equilibrium, the rate at which the reaction proceeds, and the cost of maintaining optimal conditions such as high temperatures or pressures. All of these elements need to be taken into account when assessing the overall viability and efficiency of a chemical manufacturing process. That covers everything for today, and we hope that you found this explanation helpful. If you did, please consider liking the video and subscribing for more, and we look forward to seeing you again soon.